Hello students. In class 9, we have studied the basic equations in trigonometry. Sin square theta plus cos square theta is equal to 1. This equation is true for angles of any measure. Therefore, this equation is called the fundamental identity in trigonometry. This year, we will learn some more identities in trigonometry. See this figure. This figure shows that in triangle PQR, angle PQR is equal to 90 degrees and angle PRQ is equal to theta. Let's write the 6 trigonometric ratios for angle PRQ. Sin theta is equal to side opposite to the angle upon hypotenuse equal to PQ upon PR. Cos theta is equal to side adjacent to the angle upon hypotenuse is equal to QR upon PR. Tan theta is equal to side opposite to the angle upon side adjacent to the angle is equal to PQ upon QR. Cosec theta is equal to hypotenuse upon side opposite to the angle is equal to PR upon PQ. Sec theta is equal to hypotenuse upon side adjacent to the angle is equal to PR upon QR. Cot theta is equal to side adjacent to the angle upon side opposite to the angle is equal to QR upon PQ. We have studied the proof of the fundamental identity sin square theta plus cos square theta is equal to 1. Let's revise it. In triangle PQR, by the Pythagoras theorem, PQ square plus QR square is equal to PR square. This is the first equation. Dividing both the sides of equation 1 by PR square, we get PQ square upon PR square plus QR square upon PR square is equal to PR square upon PR square. Therefore, PQ upon PR bracket square plus QR upon PR bracket square is equal to 1. Therefore, sin theta bracket square plus cos theta bracket square is equal to 1. We have studied in 9th standard that sin theta bracket square is written as sin square theta and cos theta bracket square is written as cos square theta. Therefore, sin square theta plus cos square theta is equal to 1, equation 2. Now, we will prove two more fundamental identities with the help of above fundamental identity. Dividing both the sides of equation 2 by sin square theta, we get sin square theta upon sin square theta plus cos square theta upon sin square theta is equal to 1 upon sin square theta. Therefore, 1 plus cot square theta is equal to cosec square theta, equation 3. Equation 3 is a fundamental identity. Dividing both the sides of the equation 2 by cos square theta, we get sin square theta upon cos square theta plus cos square theta upon cos square theta is equal to 1 upon cos square theta. Therefore, tan square theta plus 1 is equal to sec square theta. Therefore, 1 plus tan square theta is equal to sec square theta, equation 4. Equation 4 is also a fundamental identity. Sin square theta plus cos square theta is equal to 1. 1 plus cot square theta is equal to cosec square theta and 1 plus tan square theta is equal to sec square theta are the fundamental trigonometric identities. Now, let's solve some examples with the help of these identities. We have learned how to find solutions using the K method. Now, let's find solutions to some examples with the help of fundamental identities. First example. If sin theta is equal to 5 upon 13, then find the values of cos theta and tan theta. Solution: if sin theta is equal to 5 upon 30, we have the fundamental identity sin square theta plus cos square theta is equal to 1. Therefore, 5 upon 13 bracket square plus cos square theta is equal to 1. Therefore, cos square theta is equal to 1 minus 5 upon 13 bracket square is equal to 1 minus 25 upon 169. Therefore, cos square theta is equal to 1 minus 5 upon 13 bracket square is equal to 169 minus 25 upon 169. Therefore, cos square theta is equal to 144 upon 169. Therefore, cos theta is equal to square root of 144 upon 169. Therefore, cos theta is equal to 12 upon 13. Now, tan theta is equal to sin theta upon cos theta is equal to 5 upon 13 upon 12 upon 13. Therefore, tan theta is equal to 5 upon 12. Therefore, cos theta is equal to 12 upon 13 and tan theta is equal to 5 upon 12. We can verify this using the K method. Second example. If 40 sec theta minus 9 cosec theta is equal to 0, find the values of sec theta and cosec theta. Solution: 40 sec theta minus 9 cosec theta is equal to 0. Therefore, 40 sec theta is equal to 9 cosec theta. Therefore, sec theta upon cosec theta is equal to 9 upon 40. Therefore, 1 upon cos theta upon 1 upon sin theta is equal to 9 upon 40 because sec theta is equal to 1 upon cos theta and cosec theta is equal to 1 upon sin theta. Therefore, 1 upon cos theta into sin theta upon 1 is equal to sin theta upon cos theta is equal to 9 upon 40. Therefore, tan theta is equal to 9 upon 40 because sin theta upon cos theta is equal to tan theta. This is our first equation. We have the fundamental identity 1 plus tan square theta is equal to sec square theta. Therefore, 1 plus 9 upon 40 bracket square is equal to sec square theta. Therefore, 1 plus 81 upon 1600 is equal to sec square theta. Therefore, 1681 upon 1600 is equal to sec square theta. Therefore, sec theta is equal to square root of 1681 upon 1600. Therefore, sec theta is equal to 41 upon 40. Equation 2. Cot theta is equal to 1 upon tan theta. Therefore, cot theta is equal to 1 upon 9 upon 40 from equation 1. Therefore, cot theta is equal to 40 upon 9, equation 3. Now, by the use of fundamental identity, 1 plus cot square theta is equal to cosec square theta. Therefore, 1 plus 40 upon 9 bracket square is equal to cosec square theta. Therefore, 1 plus 1600 upon 81 is equal to cosec square theta. Therefore, 1681 upon 81 is equal to cosec square theta. Therefore, cosec theta is equal to square root of 1681 upon 81. Therefore, cosec theta is equal to 41 upon 9, equation 4. Therefore, sec theta is equal to 41 upon 40 and cosec theta is equal to 41 upon 9. Now, prove the following equation. Sec theta minus tan theta is equal to cos theta upon 1 plus sin theta. Let's solve and prove this. Solution: sec theta minus tan theta is equal to 1 upon cos theta minus sin theta upon cos theta, because sec theta is equal to 1 upon cos theta and tan theta is equal to sin theta upon cos theta. Therefore, sec theta minus tan theta is equal to 1 minus sin theta upon cos theta is equal to 1 minus sin theta upon cos theta into 1 plus sin theta upon 1 plus sin theta, because multiplying the fraction by 1 plus sin theta. Therefore, sec theta minus tan theta is equal to 1 minus sin square theta upon cos theta into 1 plus sin theta, because a plus b into a minus b is equal to a square minus b square. Therefore, sec theta minus tan theta is equal to cos square theta upon cos theta into 1 plus sin theta, because sin square theta plus cos square theta is equal to 1. Therefore, sec theta minus tan theta is equal to cos theta upon 1 plus sin theta. Hence, proved. Now, eliminate the theta from the given equations. X is equal to minus 2 plus 13 cos theta and y is equal to 3 plus 13 sin theta. Solution: x is equal to minus 2 plus 13 cos theta. Therefore, cos theta is equal to x plus 2 upon 13, equation 1. Y is equal to 3 plus 13 sin theta. Therefore, sin theta is equal to y minus 3 upon 13, equation 2. Now, sin square theta plus cos square theta is equal to 1. Therefore, y minus 3 upon 13 bracket square plus x plus 2 upon 13 bracket square is equal to 1. Therefore, y minus 3 bracket square plus x plus 2 bracket square is equal to 13 square. Therefore, y minus 3 bracket square plus x plus 2 bracket square is equal to 169. What did we learn? We studied two fundamental trigonometric identities and their applications. 1 plus tan square theta is equal to sec square theta and 1 plus cot square theta is equal to cosec square theta with the help of the basic fundamental trigonometric identity sin square theta plus cos square theta is equal to 1. Exercise: solve the following examples. If cosec theta is equal to 61 upon 11, then find the values of sin theta, cot theta and tan theta. If sec theta is equal to 2 upon square root of 3, then find the value of 2 tan theta upon 1 minus tan square theta. If 4 sin theta minus 3 cos theta is equal to 0, find the values of sec theta, cos theta and cosec theta. Prove that sec theta minus 1 upon tan theta is equal to tan theta upon sec theta plus 1. Eliminate theta from the given equations. X is equal to 3 cosec theta and y is equal to 4 cot theta.